Hey class, if some of you are struggling with tonight's worksheet, maybe this will help you. So we are talking about factors and zeros. Let's clarify some terms again. Factors, you want to think parentheses when you see factors, and zeros are what happens when a graph crosses the x-axis. So think of it that way. Factors are parentheses, zeros are what happens are at the points where it crosses the x-axis. So let's look at just a general sketch real quick. So here I have this wiggly odd degree polynomial. It's odd because I have a down-up pattern. I know my leading coefficient is positive because it ends up. I know that it has, let's look at how many turns. I have one turn here, I have a turn here, a turn here, and a turn here. So since it has 4 turns, that means it's one more on the degree. It's a degree 5 equation. A degree 5 can have up to 5 zeros, but this particular one only has a zero at 3 points. -4, -2, and +1. So if I wanted to write this equation, I would have to figure out what the imaginary other 2 roots are, which we're not going to do right now. So let's look at number 13 from your worksheet. All right, on number 13 it tells us that the zeros are located at 5/3, 1, and -1. So from here I need to put this in factored form. So I have, let's start with the easy ones. If I have a -1, okay, I'm actually thinking to myself, x equals -1. So now when I solve this, go backwards, and I set this equal to 0, I have to add 1 to both sides. So here's my first factor, x plus 1. So if x equals 1 here, that means when I set this equal to 0, I have x minus 1. That's my other factor. Now for the 5/3. This one's a little bit weirder. So if I'm going to set x equal to 5/3, and I want to clear out that right side, well, I have to multiply both sides by 3, and then I'm going to divide both sides, subtract both sides by 5. And that's where I get my third factor, 3x minus 5 equals 0. So now I'm going to take those 3 factors, and I'm going to write it in my function notation and list out my factors this way. So we're just working backwards from what the rest of the beginning part of the worksheet was. So I want to be smart about this here. I notice that x minus 1, x plus 1 is going to give me a nice difference of squares. So that doesn't require a whole lot of brain power. I just know it's going to be x squared minus 1 when I FOIL it out. Now I'm going to FOIL out these 2. Okay, so the f is 3x cubed. The o is -3x. The I is -5x squared. And the L is +5. And then just to clean this up, I don't have room for it right now, but to clean it up, you're just going to move these 2 guys places so I can go in descending degree order. Okay? So that's writing the polynomial function. So now what do we do when we have a problem like number 15, where they give us the polynomial function and then we have to do everything else? So which means now I have to figure out how am I going to factor this so that I can find the zeros. Well, whenever you see a trinomial, you want to see, first of all, is there a greatest common factor? And there is. I'm going to GCF this. GCF is x, so I'm going to pull it out. And I'm left with that trinomial. That trinomial is factorable. If you want to, let me do some diamonding on the side here. I've got a positive 1 on top, a negative 2 on the bottom, so the only way two numbers can multiply to a 1 and add up to a negative 2 is a negative 1, negative 1. So the factors are x minus 1, x minus 1. Well, now that I have my factored form, I can set this equal to 0, and I can grab my 3 zeros. X equals 0 here, x equals 1 here, x equals 1 here. Well, since x equals 1 two different times, I really only have to list it out once. So my zeros are at x equals 0 and x equals 1. If I had to sketch a quick graph of this, all this means is that I have a down-up graph that crosses at 0 and it crosses at 1. Let me change colors real quick. So it crosses at 0, it crosses at 1, and that's it. Something like that, okay? So let's just set up number 17. On number 17, now we have a 4th degree, which means I could have up to 4 zeros. I don't know if I will or not. Whoops. But I'm going to see what happens. So don't be thrown off by the 4th power. Let's just think of this as a quadratic, but instead of an x and an x, we're going to go x squared, x squared. So the only pair of numbers that multiplies to a negative 30 and adds up to a negative 1 is a minus 6 plus 5. So now to find our zeros, I set it equal to 0. I set each one of my factors equal to 0. And then I just solve for x in both equations. So that's what I have so far. To get rid of a square, the opposite operation is square rooting. So my square and my square root cancel each other out. And I am left with x equals plus or minus the square root of 6. That gives us 2 x-intercepts right there. And right here, I have x equals plus or minus the square root of negative 5. Well, that's not a real number. Since that's not a real number, I'm not going to pay any attention to it right now. And I'm only going to pay attention to my real intercepts. Does that make sense? I hope it does. This will be on your quiz tomorrow, so I hope you're ready. Have a great evening. I hope you've already had a nice, healthy dinner, and I will see you tomorrow. Bye.